Reflections. After watching this video, I will be able to draw reflections in the coordinate plane. So a reflection is another type of transformation, which is taking your image or a figure and flipping it over any given line. And I like to think about taking a piece of paper, folding it, and whenever you have something on one half of that paper, it comes in reverse or flipped on that other half. So we're flipping it over a given line. So depending on the line that we are flipping on the coordinate plane is going to determine the rule or formula that we would have to follow. So below are the common lines used. These are not the only type of reflections that we can have. We can have a great variety because our lines could be any given line, but these are the common ones. So let's look at how a reflection would look without a rule, and we can use this basically for any line given. So because a reflection is across the x-axis, that's basically saying that we're taking our little grid and we're folding it across the red line. So I know that my picture would end up somewhere in this box to the top. So if I didn't have a formula for a reflection over the x-axis, I would just count the distance my point is from that line. So D is one distance away from x, so one distance away from x is my D prime. E is 1, 2, 3 distances away, so 1, 2, 3 units away. C is 1, 2, 3, 4. So 1, 2, 3, 4. And as you can see, this would be the reflection because now my image has flipped over this red line. And if we had this on paper, we would be able to fold them together and they would align. Now, sometimes when you actually have the y-axis, when you have the grid, it's very easy to count. But if you did not have the grid and you just had the points, well, then you can actually find the vertices by using the formula. So first, let's do it by just using our graph. So our y-axis is the vertical line, and we would count the distance away. So G prime, F prime, H now is actually in the opposite direction. And it's very easy to get confused, especially when you are on paper and you're using the same color. And this would be my image when I flipped it over the blue line. Now let's look at the ordered pairs to see how the rule would have applied. So these would be the ordered pairs for each of the vertices. And then we have the rule that was in our rules page that tells me x comma y is going to equal negative x comma y. And that negative just means opposite. So I would not make the numbers negative. I would make them opposite of what they are. So if it's a negative number, I would make it positive. And if it's positive, I would make it negative. And the y coordinate would be the same. So my new ordered pairs would be opposite x, so negative 2, y stays the same. Opposite 3, negative 3, so positive 3, y stays the same. Opposite negative 1, so positive 1, 4 stays the same. Opposite negative 2, so positive 2, y stays the same. And if you compare my red coordinates with my blue image, you'll see that they match up. So whether you have the graph or the ordered pairs, you can actually find the vertices. Now you try, look at the reflection across the x-axis, look up what the rule should be, and choose the correct response below. Here we have the reflection across the y equals x line, And that's just a line that's cutting through your coordinate plane diagonally. So we're going to see by using our rule what are the vertices of our new image. So our rule for the reflection across y equals x is to take your x and y ordered pair and basically just switch the numbers. So our C prime is going to be 1, 3. Our D prime is going to be 4, 4 still, because you can't really switch those numbers. And then our E prime is going to be 1, 5. We're just taking the X, Y numbers and we're switching their places.